A dog walks across the living room and stops in front of a board full of buttons. Each button plays a recorded word. Outside, food, play, love you. The dog lifts one paw and presses outside. The owner looks over. Do you want to go outside? Then the dog presses another button. Love you. For a second, the room goes quiet. The owner laughs, maybe even gets emotional, because it feels like the dog just said, I love you, and I want to go outside. But this is where the mystery begins. Did the dog truly understand both words? Did it choose them on purpose? Was it trying to combine two ideas? Or did the human in the room connect the dots? Because that is what human brains are built to do. This is why talking button pets are so fascinating. They show us that animals can learn signals. A dog can learn that pressing outside makes the door open. It can learn that food gets food. It can learn that play gets attention. That is real communication. But it is not the same as speaking English. A dog may know that outside leads to the door opening. That does not mean it understands grammar or that it has a full human sentence forming in its mind. And this is where things get difficult. A dog may press a button because it understands the word, but it may also be following a familiar routine, watching the owner's body, or choosing the button that usually gets the biggest reaction. In a real home, those explanations can blur together, and that is the real problem scientists face. Animals may be communicating with us more than we realize, but humans are also very good at imagining meaning, especially when we love the animal in front of us. So before we ask, can humans ever talk to animals? We have to ask a harder question first. How do we know when an animal is truly communicating and when we are accidentally writing the script for them? So how do scientists stop us from putting words in their mouths, even when we swear we didn't? How do scientists stop us from accidentally putting words in an animal's mouth, even when we swear we are not? In the early 1900s, clever Hans stood before city crowds with one hoof lifted over the pavement. Someone asked a question, what is 7 plus 3? Hans tapped. 1, 2, 3. The crowd counted with him, breath held, until the hoof landed on 10 and stopped. For a moment, it looked as if a horse had stepped across the border into human language. But the twist is not that Hans was foolish. It is that the humans were broadcasting the answers without noticing. When investigators tested him, the miracle cracked. If the questioner knew the answer, Hans often stopped at the right number. If the questioner did not know, Hans suddenly failed. He was not calculating. He was reading people. A tightening shoulder, a held breath, eyes sharpening near the target, the tiny release when everyone thinks, there it is. That is unconscious cueing, the classic trap in animal communication. A pattern is not meaning if the animal could be following our posture, timing, past reinforcement, selective memory, or the story we want to believe. With pets, the danger gets stronger because they live inside our routines and we live inside our hopes. That is why translator apps, viral training clips, and touching my animal understands me moments need caution. Your face, your pause, your excitement, even your expectation can become the real instruction. So the standard is simple and demanding. Remove the human who knows the answer, hide the cues, test what remains. Then ask the harder question. If we strip away human signaling, do any animals still send a message that is clearly encoded in the signal itself? The dance looks like chaos until the hive floor turns into a map. A forager vanishes into the hive. Bees crowd the wax. Then she starts, a tight loop, a trembling straight run, another loop, repeat. To us, it looks jittery. To the hive, that waggle run is coordinates. The comb becomes a compass. Because the dance is vertical, gravity gives a reference line. The angle of the waggle points to a direction relative to the sun. Duration and tempo carry approximate distance. Longer waggle, usually farther flight. This is not a bee saying flower. It is a native format. Movement and timing, meaning roughly fly this way, search about this far. That is why the honeybee waggle dance is one of the clearest animal messages we can decode. Its power is prediction. Measure the angle and duration, and researchers can estimate where recruited bees should search. Move the feeder, and the dance changes. Other bees leave the hive and fly into the indicated range, as if the dance contained usable navigational data, because it does. The proof is not just the dancer's pattern, it is the receiver's response. The dance is not performance. It is information strong enough to guide animals across a landscape, and that changes the question. Animal signals can carry specific information, direction, distance, identity, alarm, without becoming words, sentences, or grammar. A code can be real, measurable, and useful, even when it never sounds like speech. The modern goal is not to make animals talk like us. It is to learn their native formats, movement, scent, rhythm, posture, sound, and test what each reliably encodes. If bees can send information this cleanly, what happens in animals closer to us, ones that can learn our symbols on purpose? Underwater, a bottlenose dolphin waits for a command. No wild dolphin would hear. Surfboard, left hoop. The signal is not a natural call. It may be tones or a trained hand gesture. First comes the object, then the action, then the direction. Change the order, and the correct response changes. When the dolphin completes it, the surprise is not English. It is more precise. A non-human mind has learned to use a symbolic system humans invented. So yes, animals have crossed from simple cues into shared symbols, but only in controlled training. The bridge exists. It is narrow, deliberate, and carefully built. Alex, the African gray parrot studied by Irene Pepperberg, remains one of the strongest cases. Place objects before him: green wood, blue metal, different shapes, materials, and numbers. Ask for color. Ask for shape. Ask what is the same. Ask what is different. The evidence is not one lucky answer or one charming phrase. It is the pattern: changing questions, changing objects, and labels that still fit the task. In limited forms, Alex appeared to connect sounds with concepts and use those labels flexibly. Apes offered another bridge. Instead of speech, they used signs or lexigram boards, touching symbols for foods, objects, actions, and requests. Some combinations looked purposeful, revealing serious symbol learning, but the evidence carries a caution label. Researchers still debate how spontaneous the combinations were, how much depended on training history, and how often humans shaped the interpretation. The careful takeaway remains meaningful. Apes can learn many symbol-to-meaning links, while human-like grammar remains a higher and disputed bar. The dolphin work raises the ceiling because order mattered. In the 1984 bottlenose dolphin experiments, animals learned artificial acoustic and gestural codes, then followed structured commands involving objects, actions, and directions. This was not decoded dolphin conversation. It was trained comprehension inside a human-designed code. The achievement is real because the boundary is clear. Together, parrots, apes, and dolphins show that cross-species symbolic understanding can happen. They do not show natural, open-ended, human-style language. That distinction matters now. Labels, routines, and choice systems can help animals request, refuse, choose, and cooperate. For pets and captives, talking tools are most valuable as welfare and enrichment, not proof we translated private thoughts. But if trained symbols can work so well, why does translating wild communication, like whale song, become so much harder? Deep below sunlight, hydrophones catch a storm of clicks. On land, those clicks become timing lines. Sperm whale codas appear as repeated rhythms, with subtle shifts in tempo, pause, and sequence. The AI sorts them into neat boxes. Then comes the question that breaks the spell. Now prove any box means anything. This is the locked door. AI can find structure at a scale no human listener can match. It can group call types, recognize individuals, detect rhythms, predict what often comes next, and show that sperm whale codas contain organization rather than random noise. That is important. It is not translation. The latter has 3 layers. First is pattern, repeated shapes and sound, like rhythm, timing, tempo, and sequence. Modern bioacoustics is powerful here. Second is information. A sound reliably points to something beyond itself. It may identify the caller, mark a social group, or change when boats are nearby, stress rises, or animals coordinate movement. AI helps by searching vast recordings for signals humans would miss. Third is meaning, and meaning has to be grounded in life. Who heard the call? What happened before it? What changed after it? Did another whale approach, answer, guard a calf, or turn away? That is why audio alone is not enough. Context matters. Receiver responses matter. Careful playback experiments matter. If a signal is played under controlled conditions and produces a predictable response, researchers move closer to understanding function. Not a subtitle, not a sentence. A tested link between sound and outcome. Here is the twist. A researcher can watch the AI cluster codas into clean types. The model may even predict the next pattern with eerie accuracy, But when someone asks, what does type B mean? The only honest answer is, we don't know yet. That answer is not failure. It is discipline. It is also how you spot hype. Any app promising instant whale to English translation is skipping the grounding step. Generating realistic whale-like sounds is not understanding them, and releasing those sounds into the wild could confuse, manipulate, or stress animals we are trying to protect. The real near-term promise is conservation, identifying individuals, tracking populations, detecting distress, measuring damage from human noise, and helping us quiet the ocean before we pretend we can speak for it. So if universal translation is a fantasy, what would a realistic future of talking with animals actually look like, and what risks come with knocking on that door? Out on a small boat, a scientist holds one finger above a button. Press it, and a speaker sends a whale-like call into black water. The model is trained, the signal is convincing. The scary part is no longer that the ocean might ignore us. It is that someone in the dark might answer. That is where the fantasy breaks. The future is not animals speaking English or living under human subtitles. The real milestone is harder, understanding a signal inside an animal's world before we decide we have the right to use it. At home, that starts without a gadget. Watch posture, gaze, distance, and the body's vote. Leaning in, turning away, freezing, softening, approaching, retreating. Stop calling endurance love. Stop treating tolerance as consent. Offer choices, a hand they can approach, a place they can leave, a cue for yes, and a cue for not now. Sometimes the clearest conversation is an animal allowed to refuse. Other bridges will be narrow and species-specific. Some animals may learn limited shared symbols in careful settings. AI may help researchers identify individuals, detect stress calls, track migration shifts, or flag dangerous noise before harm spreads. The strongest tools may listen more than they speak. Warnings that slow ships, maps that protect corridors, systems that help humans get out of the way. Because pressing play is never neutral. A convincing call could lure a whale toward traffic, separate companions, disturb mating, or drop our guests into a society we barely understand. Communication is influence. Influence becomes manipulation when welfare stops coming first. So distrust instant translator products that promise magic. Ask what was tested, in what context, and whether the animal's life improved. Support technology that reduces harm, not curiosity that forces performance. Be skeptical of subtitles. Be serious about signals. The goal was never to make animals sound more human. It was to become humans worth answering. If you could ask one question your animal could reliably answer, what would it be? If you like this video, don't forget to like, share, and subscribe to stay tuned for future videos.